Hello everyone, I am Lokendra and I am chemistry faculty at Toppers Academy. Today we are going to deal with a very famous topic of chemistry, that is limiting reagent. Okay, and I am definitely sure that after seeing this video you will be able to find a limiting reagent in a reaction in just 5 to 10 seconds. Okay, so limiting reagent, we are going to deal with the topic limiting reagent. So first of all we will know that what is the limiting reagent. Okay, so limiting reagent is any reactant in a chemical reaction so which consumes first, okay, and will decide the amount of product. Okay, and how it will define the amount of product we will see. Okay, so it consumes first in a given reaction. Okay, that is the limiting agent. So I am going to take very basic examples of day-to-day life, okay, that we see in our day-to-day life, and then I will correlate this day-to-day examples to my topic, that is limiting reagent. Okay, so see, if we see that one pant, okay, plus one shirt, okay, it is going to give a one dress, right, one dress. So if one pant and one shirt is going to one dress, so obviously if I am taking the pant, number of pants are 3 and number of pants is 3 and number of pant is shirts is 3, so obviously 3 dress will be formed. Okay, see, 3 dress will be formed. And if I am going to take 5 pants, 5 shirts, so obviously 5 dresses will be formed. Okay, listen, if I am going to take suppose 4 pants and 6 shirts, okay, so definitely then the how many dresses will be formed in this case. So listen, there are 4 pants and 6 shirts, so in this case if you see, only 4 dresses will be formed. Okay, 4 dresses will be formed. According to the number of shirts, 6 dresses must be formed, but for the formation of 6 dresses, 6 pants must be also there, right? But there are only 4 pants, so this number will decide the amount of product, that is the number of dresses that will be formed. Okay, so 4 pants, 6 shirts will make 4 dresses. Okay, in another case I am taking suppose 5 pants and suppose 3 shirts, so in this case 3 shirts, in this case only 3 dresses will be formed. Okay, 3 dresses will be formed. So here number of shirts is deciding the amount of product which is less. Okay, the number of shirts is going to decide the number of dresses that will be formed. Okay, similarly I am taking another example, that is see, suppose one left shoe plus one right shoe is going to make one pair of shoes. Okay, one pair of shoes, one left shoe and one right shoe is going to make one pair of shoes, right? Similarly 3 left shoes, or I'm going to take I can take another number, suppose I am going to take 4 left shoes with 4 right shoes will make 4 pair of shoes. Okay, 4 pair of shoes. And if I am going to take number may be anything, suppose I am going to take 5 left shoes and 7 right shoes, so there will be a formation of only 5 pair of shoes. Okay, 5 pair of shoes. Now the deciding factor is the number of shoes and it is deciding the product, that is shoes, pairs of shoes, that there will be only 5 shoes, 5 pair of shoes will be formed in this case. Okay, so similarly limiting reagent, I am going to correlate the limiting reagent. Okay, see, if there is a reactant A and it is reacting with another reactant with B and forming the product B. Okay, suppose we are given the number of moles of these reactant, number of moles of these reactant. Suppose 1 mole is reacting with 1 mole, and product is also forming, 1 mole of product is going to form here, right? Suppose I am taking 3 mole of this, 3 moles of this, so obviously 3 moles of the product will be formed. Okay, suppose I am going to take it 2 moles and this is 4 moles, so now 2 moles of the product will be formed, or I can say that here the limiting reagent is 2, which is less in number. Okay, here the less in number was in this case number of pents, that were 4, this was 6, so limiting entity pents. In this case 5 pents, 3 shirts, the number of shirt is less, so this is the limiting entity. Okay, in this case 5 left shoes, 7 right shoes, the limiting entity is a number of shoes, that is 5, because it is less in number, right? Similarly, we deal in this topic as we deal in our day-to-day life. In the same case, we deal with in the case of limiting reagent, then we have to find the limiting reagent in a given reaction. The number of moles of A is 2 and the number of moles of B is 4. So what is less? That is the number of moles of A. That is, A is limiting reagent in this reaction. Okay, and it is going to decide the amount of product that will be formed here. Okay, suppose I am taking 5 moles of this and 3 moles of this. Now the lesser number is here 3 moles. Okay, and between 5 and 3 is lesser, so the limiting reagent in this case is B, and it will decide the amount of product. So out of these 2 reactant, one will be the limiting reagent. In this case, when 2 moles of A reacts with 4 moles of B, the limiting reagent is A, and if 5 moles of A reacts with 3 moles of B, the limiting reagent is B. Okay, so how this is how we deal with limiting reagent. Okay, we can find the limiting reagent in this way only when then the stoichiometric coefficient is 1. Okay, if the stoichiometric coefficient is not 1, then we will see how we can find the limiting reagent in that reaction, in that cases. Okay, so here the limiting reagent is here we can find the limiting reagent, but it is applicable only when the stoichiometric coefficient of reactants is 1. So you can see the examples of such type reaction. Suppose H2 plus I2 gives 2Hi. So here stoichiometric coefficient, actually what is the stoichiometric coefficient? It is the value which is written before the reactant. So here 1 is written, we can assume that 1 is written before H2, 1 written is before before I2. So stoichiometric coefficient here is only 1. Okay, so in such type of these reactions we can find the limiting reagent in this way. Okay, so suppose N2 plus O2 gives 2NO. This is another example. Here also we can find the limiting reagent. Suppose we are given 4 moles of N2 and 6 moles of O2, then obviously N2 is the limiting reagent because it is lesser in number. Okay, so this is how we can find the limiting reagent at first in just 2 seconds or 1 second. Okay, so now we are going to deal that cases where the stoichiometric coefficient is not 1. Okay, so listen carefully. Suppose I have a watch in my hand. Okay, so one dial with 3 needles. Okay, one dial with 3 needles is going to make one watch. One dial with 3 needles is going to make one watch. Obviously 2 dials with 6 needles will form 2 watches. Similarly, 4 dials with 12 needles will form 4 watches. Okay, now listen carefully. If I take 3 dials and 15 needles, what will be the number of watches that will be formed in this reaction? So see, according to the number of needles and according to the number of dials, so according to the number of dials, 3 watches must be formed, right? But according to this number, if 3 needles form 1 watch, so 15 needles form with 5 watches. But for the formation of 5 watches, we must 5 dials. We must have 5 dials, but there are only 3 dials. So we will decide the number of watches that will be formed according to the number of dials here, because it is lesser in the number that that is required. Okay. So this is the dial is the limiting agent, and it will decide the product, and so 3 watches will be formed, not 5 watches, right? Similarly, I am taking suppose 3 dials, okay, and 6 needles, 3 dials and 6 needles. So according to the number of dials, 3 watches must be formed, and according to the number of needles, if 3 forms 1 watch, so 6 needles will form 2 watches, right? But for the formation, so now we see that what will happen according to which reactant the product will be formed. So according to which entity the final product will be formed. So for the formation of 3 watches, according to the number of dials, 3 watches will be formed. According to the number of dials, 3 watches must be formed. But for the formation of 3 watches, we must have 9 needles. But we are having only 6 needles. Okay. So the product will be defined by the help of number of needles. As 3 needles are forming 1 watch, so obviously 6 needles will form only 2 watches. So it is the limiting agent, and this will be the number of product that will be formed according to this scenario. Okay. Now I am going to deal with the any chemical reaction in which the stoichiometric coefficient will not be only 1. Okay. So I am going to take example. Suppose N2 plus 3H2 gives 2NH3. Okay, N2 plus 3H2 gives 2NH3. So according to this, 1 mole of N2 is reacting with 3 moles of H2 and going to form 2 moles of H2. Okay, NH3, sorry. So if I take 2 moles of this, so it will react 6 moles of this and will form 2 moles of NH3. Okay. Suppose I take it 4 moles. I take it as 4 moles, and I take it as 9 moles, right? So if we see the N2 and H2, so 1 mole of N2 requires 3 moles of H2. So 4 moles of N2 will require for these are 12 moles of H2, but there are only 9 moles. It is the limiting agent, and because of with the help of the number of moles of H2, we will define the number of NH3 molecules, number of NH3 moles that will be formed in this reaction. Okay, so 3 moles is going to form 2 moles of NH3, so 9 moles according to 2 upon 3 into 9, we can solve it, right? So the limiting agent is our H2 here in this case. Okay, limiting agent is H2. So this is applicable where the stoichiometric coefficient is not 1. So we deal with in this way. Okay. So I am going to recall this. One dial, we saw that one dial is and 3 needles form 1 watch. So obviously according to this, 2 dials with 6 needles will form 2 watches. Okay, and in this way I have written all this. But if we will take 3 dials and 15 watches, So according to the number of dials, the number of watches will be formed, because it is the limiting reagent. Because for the formation of it will decide the amount of product and it will be consumed first. So it is the limiting agent. In this scenario, if I am going to take 3 dials and 6 watches, so watches will be consumed, needles will be consumed first, and this will decide the amount of product, that is number of watches that will be formed. So I apply this on a reaction in which N2 plus 3H2 gives 2NH3 is it is our balanced chemical reaction. Okay, and one more thing, if we want to find the limiting reagent in our chemical reaction, then our chemical reaction must be a balanced chemical reaction. Okay, if it is not, then we will have to balance it, and then we will check the limiting reagent in our chemical reaction. Okay, so this is the way that we in which we can find the limiting reagent. Okay, I'm going to tell one more thing, that how we can find the limiting reagent. Okay, so see, if suppose N2 plus 3H2 gives 2NH3 is given, suppose random number of moles are given there, 50 moles, number of moles are given here, 50 moles. Suppose here 300 moles are given, then we will find the number of limiting agent. We can find the number of which is limiting agent with the help of the method that I have told in the previous slide, but now we can solve it in another way. We will have to calculate the value of moles upon stoichiometry. Moles upon stoichiometry. Stoichiometry, what is stoichiometric coefficient? What is the value which is written before the reactant in a balanced chemical equation. Okay, so number of moles and the stoichiometric coefficient divide. So the value for which reactant moles of stoichiometry value will be less, that will be the limiting reagent. Okay, so I'm going to, this is the number of moles. I'm going to solve this. We are going to calculate moles upon stoichiometry. Moles upon stoichiometry. Okay, so 50 moles, which is given in the question. Okay, and stoichiometric coefficient, there is nothing value, there is none value is written before the N2 reactant. So I can assume here 1. Okay, so 50 upon 1, so it is 50. Okay, and 300 upon, what is the stoichiometry value? It is 3, the value written before H2 molecule, right? So we will divide it by 3, so it is 100. So the reactant for which moles upon stoichiometry is lesser, that will be our limiting reagent. So here the value is 50, the value is 100, so it is lesser, so N2 will be the limiting reagent. Okay, we can solve in this way also. Okay, now I'm going to discuss 3 cases in which we generally deal in different type of questions. Okay, so see, so maybe that we are given number of moles. The simplest way, we can calculate number of moles upon stoichiometry, then we'll be able to define the limiting reagent. Okay, now another way, maybe the amount in grams given. Another way, in another question, you may have the value of volume. So volume in liter or ml also. Okay, in another case, you may have the value of molecules of reactant. Okay, so how we will deal in all the cases to find the limiting reagent in a given chemical reaction? So see, I will take only one equation and will take all these cases with that particular equation, balanced equation, that is N2 plus 3H2 gives 2NH3. Okay, so see, N2 plus 3H2 gives 2NH3. Okay, so suppose we are given 3 moles of this and 10 moles of this, moles. Okay, this is the number of moles. So we this is very simple. We will have to find the number of moles upon stoichiometry. Okay, so 3 upon stoichiometry is 1. Number of moles is 10, stoichiometric coefficient is 3, so it is 3.3. So in which case it is lesser, the value of moles upon stoichiometry, it is 3 and it is 3.3, so it is lesser, so it is the limiting reagent. That means N2 is the limiting reagent in this scenario, okay, in this case. Okay, now I am going to deal with the second case, that is if the amount in grams of reactant is given and we are asked that what is the limiting reagent in that particular equation. Okay, so see, suppose N2 plus 3H2 gives 2NH3 is given equation, right? This is the equation that we are given. So suppose 28 gram of this and suppose 18 gram of this are given. This is the amount in gram. So in this case, first of all we will calculate the number of moles, because we have to find the value of moles upon stoichiometry, and for that we must know the there are how many moles of reactant are present in the equation. Okay, so moles, amount in gram upon molecular mass, that is for N2 14 into 2, that is 28, so there is 1 mole, and for H2 amount in gram upon the molecular mass of H2, it is 2, there are 9 moles. Okay, there are 9 moles. Okay, so now we are going to calculate moles upon stoichiometry. Okay, so moles is 1, number of mole is 1, stoichiometry is 1, so mole upon stoichiometry is 1. Mole upon stoichiometry, number of moles are 9 and stoichiometry is 3, so it is divided by 3, so it is 3. So here the value of number of moles upon stoichiometry is 3, and here the number of moles upon stoichiometry is 1, so limiting reagent obviously N2. Okay, in this case we can deal if the amount in grams is given, then first of all we will divide the amount of grams by molecular mass and we will find the value of number of moles of reactants, and then we will find the value of moles upon stoichiometry, and then we will be able to know which reactant is limiting reagent. Okay, suppose we are given volume N2 plus 3H2 gives 2NH3. Okay, suppose it is given that 22.4 moles of N2 and liter of N2 and 44.8 liter of H2 are reacting with are reacting together and forming the product NH3, then which reactant is our limiting reagent? Okay, so now what we will deal how we will deal this? We first of all we will calculate the number of moles. So 22.4 we will divide it by 22.4, so please divide it 22.4 and 44.8 divided by 22.4, so it will become 1. So 1 mole of N2 is present here and 2 moles of H2 is present here. Okay, so now I am going to calculate the value of mole upon stoichiometry. Okay, so number of moles is 1 and stoichiometry is also 1, so moles upon stoichiometry, value of moles upon stoichiometry for N2 is 1, and number of moles of H2 is 2 and stoichiometry is 3. So it will become 0.66. So it is 1, it is 0.66, so it is lesser, so H2, our H2 is limiting reagent in this case. Okay, so now I am going to deal with the last case with the same equation. Okay, suppose N2 plus 3H2 gives 2NH3 is given. Okay, now it is given that 6.02 into 10 to the power 23 molecules of N2 and 12.04 into 10 to the power 23 molecules of H2 are going to react and are forming the product NH3. Then in this reaction, which one reactant is our limiting reagent? Then how we will deal? It is the molecules, number of molecules given, right? So in this case, first of all we will find the value of number of moles. Okay, so 6.02, we will divide it by Avogadro number, that is 6.02 into 10 to the power 23, and definitely we will be able to know the value of number of moles in this reaction, right? It is 1. 12.04 into 10 to the power 23 upon 6.02 into 10 to the power 23, it will become 2 moles. So we were given the number of molecules in this case, and now we have calculated the number of moles in this equation. Okay, so we will find the value of moles upon stoichiometry 1 upon 1, because in for N2 stoichiometric coefficient is considered as 1. Actually it is 1, we are not going to consider, actually in actual it is 1. So 1, right? So 2 upon 3, because the stoichiometric coefficient for S2 is 3, so it is 0.66 and it is 1, so obviously 0.66 is lesser than that 1, so obviously it is the our limiting reagent. Okay, it is our limiting reagent. 0.66 is our limit lesser value, so obviously S2 is our limiting reagent. So there may be 4 these cases for any equation. So I have taken one equation, and that one equation I have dealt with all these 4 cases and have found the which one reactant is limiting reagent in which case. Okay, and one more thing, for this case volume and for this case molecules, suppose it is given, then we can divide. We are not necessarily bounded that first of all we have to calculate the number of moles. We can divide the volume in liter directly by stoichiometric coefficient, and the value which will be lesser, that will be the limiting reagent. I am saying that we are not bound that first of all we will calculate the number of moles and then we will divide by stoichiometry. We can divide volume in liter or in ml by directly stoichiometric coefficient, and the value of volume upon stoichiometry will be less for that for any reactant, that will be the our limiting reagent. Okay, in this case also, because that is why it's happening, because we are dividing by the same value 22.4 22.4, so it will make no effect, right? We are dividing by the same value. In this case also we are dividing by the same value, that is Avogadro number 6.02 10 to the power 23, so we can calculate. We are not bound in this case also that we first of all we will calculate the number of moles and then we will find the value of moles upon stoichiometry. We can find directly the value of molecules upon stoichiometry, and the reactant for which the value of molecules upon stoichiometry will be lesser will be our limiting reagent. Okay, see, in this case when we were finding the number of moles, we have divided by two different number. In this case N2, the molecular mass was 28. In this case, when the reactant was H2, the molecular mass was H2. So the molecular mass for N2 was 28, molecular mass for H2 was 2. This is not same. So we cannot calculate the value of amount in gram upon stoichiometry directly. It will give the wrong result. Okay. So in this case, first of all, we will have to calculate the number of moles, and then we will have to find the value of moles upon stoichiometry. In these cases, we can find the value of volume in liter or ml divided by stoichiometry, number of molecules divided by stoichiometry, right? So this is how we can deal with all these cases. So I have taken one equation and 4 different cases for that particular equation, and I have found that how we deal with each cases in a same reaction. So you can solve a question of limiting reagent, how to find the limiting reagent, and if you will be able to find the limiting reagent, so you will be able to solve a lot of questions. Actually, it is not bound that it will be asked in only one chapter, that is some basic concept of chemistry. You must know this concept, that how to find the limiting reagent for your physical chemistry also, for your inorganic also, right? For overall, if you want to deal that which reactant will be formed, what amount of product will be formed, which reactant is consumed, which is excess reagent, so you will have to know this topic, that is limiting agent. And what is the excess reagent? The reactant which is another than the limiting agent, it is excess reagent. So suppose in this equation the limiting reagent was N2, so H2 is excess reagent which is present in excess, right? So this is the excess reagent. Okay. And in this case, suppose if we have the case there is the value of moles upon stoichiometry is same. So in the same for all the reactant. If we have such case in which the value of moles upon stoichiometry is same for all the reactants, in such type of reactions there is no limiting agent, there is no excess reagent, right? Because all reactant are present in the required amount itself, so it cannot be limiting agent, it cannot be excess reagent, all are present in the required and in the right amount. Okay, so I hope that you will be able to find the limiting agent in every and each equation, in each cases, by seeing this topic with this video. And if you have any doubt regarding this video or regarding this topic, so you can ask in the comment section. Definitely I will be there to reply. Okay, thank you very much.